Excellent. Okay, so for today's video lab, I want to continue along our journey on back-end technologies. We're going to continue to explore Express. So previously, we've seen how to build our own kind of simple static web server. We've seen how to build our own dynamic web server. Well, now I want to start talking about designing our own REST APIs. And so the REST APIs you think of are the web services that provide data to either other backend services or to front-end services. So either to clients, or believe it or not, servers themselves can be clients to other services. And so the goal of this lab will be to build a multiplayer version of the HiLo game, right? So that we'll have a server that will go ahead and be able to go ahead and run our game logic. And then clients will be able to go ahead and send HTTP requests to send in their guesses. Okay. So here, the contents for today's lab is we'll do a brief little lab introduction where we'll talk a little bit about REST APIs and endpoints and routes and route parameters, because that's going to be a new thing we hadn't seen in the prior. And
hey, tráeme un poquito de agua, vieja.
Hey, we might need to okay, mute all. Perfect. Okay, so and we're going to talk a little bit about Uuids and how we can use that to go ahead and sync assets to deliver to particular clients. And so that's going to be something that's going to prime us for the concept of what we want to do with databases. So after we're done with our little lab introduction, we'll talk about some of the considerations we have for designing a REST API, where we're going to specify the functions and routes that the API will support. Then we'll start building out this app. And this app's really only like 8 steps. We're gonna, and really small steps too. The first is going to configure the package.json, because we're going to use NPM as our build tool and our launch tool for our web app. So we'll initialize the configuration file for our application and look at what we have to fill out. And NPM actually has tools where you can initialize this by default, but I think it's kind of valuable where we hand write this initially so you get an idea of what all these properties are. Then we're going to set up our Express app so that we just initialize a basic application to listen on a port. Then what we'll do is we'll set up a router and controller. So we'll listen on a route and set up a controller is going to be a callback function just to be able to deliver some test data from our web API. And so then once we get tests successful, then we'll actually start building out our game model and then have an endpoint that builds a new game. And then we'll build an endpoint that lets us get that game instance we just built. Then we'll build an endpoint that allows us to go ahead and send the server a guess for a particular game instance. And then if the game is over, we'll get the option to be able to play again, to reset the game from a game over state to a new state with a new passcode. And then the last step will actually not be something that affects us for today's lab, but rather will be used for next lab, where we build a client that'll actually use this REST API so that we can actually play this game inside the browser. So this lab and the next lab will be interconnected. Will depend on this server that we're going to build in today's lab for the next lab to actually serve as a client or to be in the role of a client for that server. And just some related labs that you might want to take a look at that has motivated this lab. Well, we already built a HiLo guess game. That's not quite spelled right. Okay. And so that will have the game logic that we'll already be familiar with. And then that quiz game with the leaderboard that we built will give you a notion of how REST clients work on the front end. And then that dynamic web server we built last lab will kind of give you an idea of what some of the backend responsibilities are in terms of setting up routes and then callback functions in support of those routes. Okay, so quick introduction for the concepts in our lab. Well, the prereqs for this particular lab are none. This is going to be the first in our REST API sequence. So the next lab will depend on this one. Just assumes a little knowledge of Node and Express and JSON, the ones that we've gone through already. The motivation behind this lab is we want to use Express to implement a REST API, because this is going to be super valuable for you as you build out your full stack applications. The goal of this particular lab is to design and implement a REST API that will build a multiplayer HiLo game, as I said before. And our learning objectives is, well, we're going to learn how to use Express more effectively. We're going to learn about route parameters, which we haven't seen yet. That'll allow us to have variable URLs. Well, go ahead and look at the request query string, because that's how we're going to send data in this version of the game to the backend server. Now, in most web applications, you'll probably want to wrap your data into the body of your request so that it's not exposed to the public. But since we're building the backend before we're building any kind of client side, for the purposes of being able to easily test it using the browser, we're just going to encode everything as a query string. So we can kind of see the behaviors from the client side and from the server side without actually having to build the client side. So that's the motivation there. We'll learn more about the use cases of Uuids, and in particular, we're going to use a module called Short ID, and I'll explain why. We'll talk a little bit about what REST API is and some design and developing considerations, and then you should be able to use this lab document as kind of a touch point, as kind of like a kingstone on how you might want to do your back end document that you'll have to turn in. Then we'll talk about some backend app logic. So you'll see some of the backend considerations are going to be slightly different, but also similar to front-end considerations. One nice thing about the backend is all of the data that we have on the backend is actually private. So you can go ahead and save things there that aren't supposed to be exposed to the public, to the general public, and you should only share to the general public that which should be knowable. And then we'll learn how to actually export our own JavaScript modules from one script to the other from the backend using a Node, the way that Node does that, as opposed to the way that the browser does that. Now, for this particular lab, our server-side architecture is, well, we'll have our root directory. I'll probably call this HiLo server instead of number guesser server. And then we'll have a package.json and app.js, and then we'll have folders to manage our routes, our controllers, and our models that we'll need for our app. So let's go ahead and make that. Let me make that directory, HiLo server. Perfect. Okay, so let me change into that. So inside of HiLo server, I'm going to need a package.json. I see that. Okay. I'll also need a app.js, and I'll need a route. I'll need a controllers, and I'll need a models. Excellent. Okay, so some base concepts that you should take away in terms of REST architecture. REST architecture is just a common approach for our backend web services to interface with other backends or front ends, like I said before. So the way that we should break this down is, first, let's define an API. That's a starting point that everyone in this class should already be familiar with. An API is a collection of pre-implemented functions or methods, right, that a developer can import or invoke. So you've been using APIs all the way since the very first programming class that you've been a part of. Now, when it's a REST API, REST just stands for representational state transfer. It refers to the use of using HTTP protocol to provide access to an API. So it's a way of providing an API. Instead of having to install it onto a local machine, you can make a request over the internet for data, and it returns it back to you. And then when we're talking about endpoints, well, the endpoint is when an API interacts with some other remote system, the touch point of this communication are considered the endpoints to that system. So for our APIs, you can think of the endpoint as the URL of the server or the service that you're trying to get access to, or that you're requesting information or data from. Okay, so again, we're going to be using more Express. And just to cover that, Express is our full web framework and server that runs on top of Node. And so the new things about Express is going to be route parameters. That's going to allow us to have variable URL routes to be defined with the callback. And we'll look at that when we get there. And then also we're going to look at how we can access not just the request body, which is what we did last time. We'll be able to see the request query. And so this can hold a query string that's located inside of the request object's query attribute. And then unique IDs are very common with backend services. Usually for backend services, usually you manage multiple unique session data for each of your clients. So like a cookie can even be considered a unique ID, but we're going to generate our own in order to track what data belongs to each client and give a unique identifier mapped to the data so that we can provide it. Now, we're going to make these unique IDs public for this application. You could think of it, if you've ever played a Jackbox game, you could think of the unique ID as like a room code so that anyone who has that room code will be able to access a HiLo game instance and play the game there. So just some things about unique IDs. UUID is the most common and most popular node module for generating unique IDs. However, for this project, we're going to use short ID, which generates human readable, and it's intended for sharing. If you go to NPM's webpage, every module that you can install, they have a documentation page. So here, we might look at this a little bit more when we actually implement it, but you can see short ID just produces identifiers that are easy to transmit. It's not a huge sequence. Like if I look at, let's look at UUID, NPM, you'll see that those, they might be more secure, but they're also huge. It wouldn't be good to be able to share. Let's see if they have a sample. Yeah, look, like this isn't something you can share with somebody easily. Whereas with short ID, we can easily like tell someone our room code, and then they can come to our game instance and play against us. Let's talk about a little bit of the design of our REST API. And so this is what your documentation should look like when you're talking about defining your REST API for your own backend service. So here, the goal is to specify the functions and the routes that the API will support. So the routes are our endpoints. In this instance, we would use paper and pencil, right, during the design phase. So before coding a REST API at all, we should first plan out the number of endpoints you intend to use and how those endpoints will interface with the controllers to interface with your backend models. And again, we're going to use like a model view controller design pattern, just like what we did on our JavaScript front-end games. So in the application step, well, there's no coding here. It's more like a design step. What we're going to do is we're going to write a table that specifies our API details. And so we're going to have a couple different columns inside of our table here. And so this table can serve as a guide for all of our future iterations as we continue to implement our backend service. And if we realize we need more routes or more functions, we can keep adding onto this table. But even as we build this out, we're going to build a function of this at a time. So we have a route that at our API at game for new using the get method and passing start and end data, we will go ahead and inside of our server create a new game that creates a new game and randomizes a passcode between whatever the start and end values that got passed in to create that new game. On the route of a variable ID, so again, we're going to use short ID to produce some random sequence. Well, we're actually going to be able to assign a route to any one of those random ID values. So if anyone goes to game / and then those ID values, they'll be able to have the option to join the game. And what it means to join a game is you get the data for an existing game using that game's ID. For this route here, we can have a sub route. So if you go to game and then a particular ID, the colon specifies that that's some random sequence. Well, a subdomain, guess, will allow us to go ahead and produce a guess, invoke the guess method for that game instance. And in this instance, we would have to pass it a value for our guess. And of course, the behavior that would be tethered to this API, to this endpoint, would be, and on the server side, we will guess a number in that game instance that's tethered to that ID, and then return whether the guess is either correct, whether it's too low, whether it's too high, or if someone already got it and we're currently in a game over state. And then if we are in a game over state, we'll also have the option for a pre-existing game. So we're so at the URL of that game to also be able to issue a reset request. And again, we're just going to use Get so that we can test this out in the browser, because the browser's default request type method is a Get request. So we'll be able to just type an address, a URL address, hit the back server and actually get data back rendered right into our viewport without having a client built yet. And so this will just reset our game with a new random number and then toggle the game over state to false instead of true. Okay, so now that we have a good idea of the design of our API, let's start making our game. So the first thing we need to do is set up our configuration file. We need to make our package.json, which we already have. Let me go over here, in fact. And yep, there we go. Here we go. Let me open this here. There we go. And so here, recall package.json is going to have all the metadata that's responsible for managing, building, and launching our node application. So let's take a look. So it's again in JSON format. And so we will have a name property, which is the name of our app. Here, I'm going to call this HiLo instead. HiLo API. I'll call this REST API. Okay, here I'll give it a version number. I'll give it a description, a backend API for HiLo number guessing game. You put for author, whatever your name is here. For main, it's going to be whatever the launch point of your web application is. So for us, we're going to create a Java file, a JavaScript file that's called app.js, and that'll be our launch point. We'll have a scripts property that is an object that can contain multiple scripts that we can launch via NPM. And recall, this was important if we wanted to go ahead and deploy this onto a hosting service like Heroku. So Heroku would invoke start, which would install all of our dependencies with NPM, and then launch the application using Node, and then whatever the launch point is. So it would be app.js. And then we do have one dependency because we're going to use Express as our web app framework. So we're going to go ahead and list that as well. So again, that is also a object or a dictionary where the keys are the modules we want, and then the values are the version. And if you just want the most up-to-date version, you can use an asterisk. Okay, so that looks just like it had done. I think we've used package.json now 2 times. Now, the next thing we can do here is we can now invoke NPM, the node package manager, to install all our dependencies. So if I go here and we type in NPM install, let's see here. Oh, we need to actually go into the HiLo server. Let's clear here, change into HiLo server. And now let's do NPM install. So that's a good example of what happens if you try to do NPM install, but NPM doesn't see a package.json file, doesn't have the necessary configuration information to know how to start it up, and then you'll get an error message. But since in this folder we have a package.json, notice it's going to then produce 2 things: node modules, which is going to be all the dependencies and the dependencies of the dependencies that we need for our application that we defined, and then a package.lock.json, which is the actual versions of the software that we're using. So that if we want to guarantee that our application will run in the future because there might be a change in one of the APIs. We can always just install off of this. Okay, so that's it. Let's move on to the next iteration. Now we just want to set up a basic Express app. So here we'll initialize an Express application and just have it listen on a port. So again, we've already seen this before. This should be an easy step for us. So one thing to remember about Express is that it supports middleware modules, and we're going to take advantage of that a little bit for this lab. And this idea of middleware modules where you can have a sequence of functions that pass your request and response objects between each other allows you to kind of break your logic down across functions and makes building backend services much, much easier. And so what we'll do is we're going to import the modules that we'll need, and we'll actually start up our Express app and start listening on a port so that we know that we actually have a server that's up and running. So really, there's just 3 steps to this particular portion, and they're all going to happen in app.js. We're going to import our modules, set up some data. So let's do that. And then we'll step through what we're importing and why we need it. So let's go here, app.js. It's going to have all of our apps, core logic. Okay, so we're going to import Express, and that's going to give us essentially a function object, and we're going to bind that to a variable. We're going to import the module path, and we're going to go ahead and bind that to a variable as well. We're going to import body parser. Body parser will allow us to view into the request body to extract data from it. And so we'll go ahead and we will store that into a variable as well. And then we're going to define a port that we'll listen to. And just to prime this for Heroku deployment, if we wanted to deploy this on Heroku, I'm going to see if there is an environmental process variable named port that already exists, and I can use that. That would be open for our application. And if there isn't, then we will just use 3000. So for development purposes, we'll be using 3000. But if you were to deploy this, Heroku will define this, and then that would be the deployed port. Okay. So the next thing we want to do is we want to actually go ahead and create a new instance of Express, actually like launch the application and then start binding some middleware modules to it. So I'll do that right under here. So here, I'll invoke the Express function, which will build an Express instance for me, which will be my app. And then the use method inside of Express allows me to go ahead and use a middleware module. So body parser.json will allow me to then go ahead and parse the bodies and read them as JSON. And body parser URL encoded will allow me to also get access to the search parameter strings to be able to parse the URLs. So again, the comments here are pretty good for this particular lab too. So you could read line by line, which each of these are doing. So one allows us to read the URLs, the other allows us to read JSONs that get sent to us. And then the last and final step in this is, well, let's just get the app to start listening to that port and listening to requests on the port. And then we'll do a console log just to let us know on the server side that our application launched. And so I'll just do that right here, app.listen, and that has one parameter, which is the port number. And then once it starts listening, we'll go ahead and let us know here where we're listening. So node, and now we're listening on port. So let's see here. That's it. Yeah, there's not much I can do. I mean, I guess I can just go to localhost and check, but I won't even bother. I'll do that in the next step. So let's go ahead and kill that. So for iteration 3, we're finally going to define a router and a controller, and this will just be for a test purpose. So here we'll define a router and controller to trigger the API to send test data in response. And so our approach here is we want to try to manage, we want to make something that's going to be scalable and manageable. So instead of putting everything in one script or putting all of our scripts together, we're going to organize them into their own directory. So notice we have a controllers directory, which is going to hold all of our callback functions that bind to our routes. And our routes will define the routes and import the controllers and bind the callback function that gets called back. And the model will have all of our model data contained within it. So here we're going to have to create a new JS file. So let's go ahead and do that. And I'm going to make that inside the controllers. So let's see here. So let's do touch inside of controllers. I'm going to create something called game.controllers. And it's not necessary that I put a dot between game and controllers. I just wanted to show you that this is something you can do and it's completely legal. But you could opt to use the typical convention and just call this game controller and use camel notation or snake notation. Okay, so I should have that. Also, let's go ahead and make a new folder, a new JS file into our routes. So let's, inside of routes, we will create something game.routes. And again, the idea behind that naming is that all of the routes and controllers explicit to the game logic would go in there. Now, if you had other logics that your app was centered around, like maybe user login or whatnot, you could have like user routes and then user controllers or things like that. Again, it allows you to be able to subdivide your app into something that's much more scalable and manageable. Okay, so now that we made this new controllers app, why don't we create a controller class that has a test method, and the test method will send a JSON data as a response, and it'll, so here, let's go over here, and inside of controllers here, bring that there. And there. So we'll make a new class. We've already seen class constructions before. We'll have a instance method. So since these are designed to be callback functions that are part of the endpoint, they have to take in a request and a response object. And since they're going to be responsible for sending the response back to the client, they'll be responsible for sending some kind of data, right, to terminate the request. And so for this instance, for testing purpose, we'll just send back as a response JSON data, and we'll encode into that object or a dictionary where the key is success, and this is either true or false. So what this implies here is, was the request successful on the server side? And the server is going to send back a message that says this success was true on this. And then what we're going to do is we are going to want to use this controller, these methods inside this controllers class outside of this module. So we will access the modules and they have the ability to export into the modules. So here, this module can then export a new instance of controller. So when some other module goes to import this module, the thing it's going to get is an instance of controllers. So it's an object that will have this function, this method of test. So now that we have the controllers defined, let's go ahead and inside of our game routes, actually set up a route that invokes that callback function. Let's go here, routes. So what's happening here is, well, I have to import Express into this module. Now, again, anytime a module is imported, it's privy just to the module it's imported to. So if I need access to something related to Express, even though I imported an app, I also might have to import it inside of my routes here. So Express actually has a built-in function that manages all of the router calls for us, and then we can register routes to the Express router. So what we're going to do here is we're going to build the router, right? We're going to invoke the router function, and we're going to bind that to a variable, and we're going to manage it inside of our own routes.js file. And then this is the first time we've seen how to do this on Node. We're going to actually import our own test function, that callback function that we defined inside of controllers here. We're going to import that inside of our routers.js file. And so we can do require. And so here we can just use a relative path inside of our project directory structure and access any other JS module that has been exported. So since this is a module, has a module.exports, I can import it here using the require keyword. So remember, the ... means from the parent of this directory. So if we look at this, we have routes and our game routes is there. So we got to go back a step. And then from this, we have controllers. And inside of controllers is the game.controller.js file. So I'm going to give the pathway relative to to this module of where to find that source code file, that module. And then since it's going to return an object, right, it's going to return an instance of controllers, I can use the destructuring call to just dereference the test method out of there. And so that way I can just get access to that one function. And so on router, right, which is the Express router that manages all the routes, we can set whether we want to tether an endpoint to be in response to a get method or a post method or delete method or a put method. So we're going to set up a get method on this route on /test. And whenever /test gets a get request, we're going to go ahead and invoke that callback function of test, which is going to send back as a response this JSON of success assigned true, or a success true, the key value pair. And then again, this router will be used, these route operations will be used external to this module. So we need to export this to the module exports so that it can get imported by our app.js is going to be the idea. And again, as I'm walking through, if you have any questions, just go ahead and put them in chat. Okay, so the next and final thing we want to do here is we want to go ahead and import our routes that we have set up into our app. So let's go into our app and let's go, I'll probably do it here. And no, not that, don't want that. So here, just like before, I can go ahead and import anything that's been exported as a module. And since this is my own module, I can use the relative path of where that JS file is at. And then I'm going to save that as routes. And so what am I storing here? What am I exporting? As routes, I'm exporting the Express router. So I'm configuring the Express router inside this JavaScript file. And after it's been completely configured, I'm going to go ahead and use it inside of my app.js. And this, again, allows me to break my logic down across multiple JS files, so it's much easier to read and update and refactor. Okay, so the next thing I need to do, though, is I want to set up a middle point for my route. So I don't want my routes to be off of the root directory. So what I can do is I can say, hey, Express, I'm going to use this route /API/game as the root directory for all of the routes defined by the Express router. So this way, I can have a collection of pages like HTML pages that are available on the root directory. But if any developer wants to access the actual REST API, they have to go through these additional endpoints /API/game. Excellent. And then that's it. The next thing we should do is let's launch our app and let's see if we can't in the browser access that test method. So let's make sure everything's saved. Let's launch node app. Our server is now running. So now let's go here. Okay, so we'll go to from localhost port 3000, right? So that's where our base service is. And then since we said that Express, when we set up this middle route, let me do it here in the code. Since we have this middle route set up as /API/games, right? Any of the callback functions or any of our REST API is going to be available from there, right? So from the local host at port 3000 /API/game, we're going to access that test endpoint, and that should invoke the callback function on our server. So if we hit that, we're going to get that JSON success true. Again, if we try to hit that endpoint from just the root directory, though, we're going to say, oh, there's no get callback function set up for that endpoint, for that URL. Excellent. So it's working. We actually built our own endpoint. So let's start building out the endpoints that will allow us to build out our game, to actually have our game be functional. So the first thing we should do is we should create a game model and implement the REST API that at least allows us to make a new game instance. And so here, we're going to be going with a model view controller paradigm. So we're going to create a model file that defines all of our number guessing game states and behaviors. And the game model will create effectively a dictionary of games. So we might want to think of this more like let's call this more like a game server model, which will create a dictionary of the games, and where a key is a game ID and the value is going to be the game object. And then each game itself must track the min, the max, the random passcode, the game over state, and its ID. So there's going to be 5 steps in building up this endpoint to create a new game. The first is we're going to have to refactor our package.json so that we can use that short ID module I was referencing earlier. And then we have to create a new, let me do that right now. I'm going to create a new JS file that's going to be inside of the models directory, and we'll call that game.model. And again, all of the logic that will be in support of the game model would go into this JS file. But if I had like user models, or if I had other things related to the app that were distinctly different than the game, then I could put that in its own JS file and organize all of my data containers, all of my data in a easy navigable way. Okay, so now I have a game.model.js, perfect. And then, well, in order to be able to build an instance of model, we'll have to refactor our controller and our routes, right? So that we can actually listen to an endpoint and invoke a controller, which will be our callback function, which will then invoke our model to build an instance of a game. So first, let's actually update our package.json, where we're going to add that new dependency. So that'll be super simple. Let's go here, package.json, and I will do a comma inside of our dependencies dictionary right here, and then put short ID. And then I just want the newest version of that. And again, if you want to read more about that, you can just go to the NPM. But the idea is to get IDs that look like this, that are relatively small and that we could share with others, because we're going to use it as kind of a room code like you use in Jackbox. Okay, so once we do that, let's go ahead and fill out our game model.js file where we create a new class that we'll call a game server class. And the game server class will be responsible for managing all of our game data. So what's going to happen is the game server will model and register games using an ID built from that short ID module. And effectively, we'll use that as a dictionary. So you'll have the short ID as the key, and then the value at that key will be a game object that we can then supply to a client that requests for it. And so whenever we build a new instance of a game, it will have two parameters that the client will have to give us. It will be what is the minimal value and the maximal value of the HiLo game. So you can actually create interesting games with those parameters. It could be between 0 to 100, 0 to 1,000, 0 to 10,000. It could be from minus 100 to 100. Okay, let's go into our models. Let's open up our game.models.js file here. And okay, so the first thing I'm going to, let's take away some of this, and so it's not a big block of code, and let's make this a little bit at a time so we can see what's happening. So the first thing I'm going to do is I'm going to go ahead and I'm going to import the module short ID, so I'll be able to use that. Then I'm going to create a new class that's going to be my game server class, and the game server class is going to have a constructor. And the constructors, the instance variable that it's going to have is going to be games collection. It's going to be a dictionary where the keys are going to be the IDs and the values are going to be all the game instances. Okay, so now that I have the ability to construct, oh, I wanted to do that. Yeah. Okay, so now that I can construct an instance of a game server, notice that's going to be the thing that gets exported to modules, so that as say, for instance, controllers needs to import the game server to be able to tell it to do things, right? It'll have this game server instance to be able to access. And then we're going to create another method here that's going to be a create method. Let's take a look at what this create method is going to do. It requires a start and an end parameter. And then the first thing we're going to do is we're going to generate our passcode, our secret number, using math.random. And then we'll multiply that, because it's going to be a random number between 0 and 1. Then we'll multiply that by whatever the ending value is. And then we'll pivot that by the starting value. So again, if this were a number guessing game between 0 and 1,000, we would just pass in 0 and 1,000. But if you wanted the start to be at 100 or like minus 100, right? Well, that allows us to go ahead and pivot the point where the number could potentially be. And then the squiggle here allows us to cast that into an integer. So it drops a fractional portion. Then short ID has a method called generate, where it just generates a random ID. Super simple to use. So we'll tell it to generate an ID, and then we'll just save that into a variable. And then we're going to create an instance of a game object. So a game object is just going to be an anonymous object, right? That has key value pairs. So it'll have a key of number, and then the variable number, that is the passcode that we generated up here. Then it'll have the key of start, and then the actual value that got passed into the create method here. Then it'll have the key of end, and then the value of end that got passed into the parameter here. Then the game over will be false. And then what we'll also do is we will bind to it this ID. So inside of the games collection, we'll use as the key the ID we generated, and then as the value, we'll bind this game instance we just created. And then just to test to make sure this is working correctly, we'll do a console.log, and we'll display this.games, which is the entire collection. And then what we'll also do is we'll return the ID back from the model to whoever invoked us to create the game, so that they know how to access it again, right? Because the only way you can get access to that game instance is using this ID as the key. No, that's not. Oh, yeah. Oh, was I? Okay, the next thing I want to do here is I want to go ahead and go into my game controllers and import my game model so that I can tell my game model to do things from those callback functions. So let's go into the controllers here, and let's, at the very top, we will go ahead and import from models, the game model. And notice we don't have to do .js when we do these imports. So even though they're JS files, as a module, you don't have to list that. And then we're going to go ahead and we're going to import the object, right? The object is going to be an instance of game server. And I'll just call that game here. Okay, so now that we have access to our game server, we can start telling it to do things. So let's create a new callback function inside of our controllers, right? That's going to take in a request response, and it will allow us to go ahead and create a new game. So inside of controllers, since this is a class, I can just define a new instance method in there. Make sure that everything is perfect. And it's weird formatting going on here. There we go. There we go. Perfect. Okay. So the new game callback function will take in a request and response. From the request, we're going to access the query string, and we're going to dereference from it. So the query string is going to have a start key and an end key, right, with values. So we want to dereference from the query object, the start and the end, and then we're going to pass that to our game model here, our game server model, to the create method we just made, and we're going to send that as our start and end. And so if that's successful, right, if that's successful inside of our game model, that's going to return back an ID. So we're going to get back an ID and we're going to save that. And so in the response, when we send back a JSON to the client, we're going to say that the request they did, it's true, it was a success. So we're going to give some meta information about the request. And then we're also going to give information they're going to need. We're going to create a key that's called game ID, and we're going to pass in the value of the ID that the model gave to us. And then the next thing we have to do is we got to go into our routes and actually set up a route to invoke that callback function. So we're going to have to import. Let's go back into our routes here. And right now we're just doing tests, but what's that method we just created? Was it called New Game? Let me check here. It was New Game. So since I'm already destructuring things using this, I'll just go ahead and also destructure New Game so that I don't have to do dot operators, right? Like I could have just imported the object and then done something like controller.task, controller.newGame, but I like the syntax of this better. Okay, so once we import that callback function, we have reference to it, we can set up the express router to set up a new route. So here, this is also going to be everything we're going to do for this lab is going to be get. We're going to listen on gets. We're going to listen to new and invoke the new game function. Okay, perfect. And now let's go ahead and run that and see if that doesn't go ahead and start, and we can do some tests on that. So let me grab our test. And so here, let me kill the server. Clear that so we can see. Let me run my app. Let me do npm install, because it let me know, hey, you're trying to use a module short ID and you haven't used that. So that's why I used npm start actually here. So if I paid attention to my actual directions, let's see if that should have installed the new and then start running it. Perfect. Okay, so now that that's running, let's go back over here. Let's test this. So we still have that test because we never removed that. But now let's do this. Let's go to localhost F3000, and then all of our API is at API/game because we set that up in the Express app using the middleware. And then here, this is going to be the new route, right? We set this up for new games on /new, but also the new route is using search parameters, right? If you recall, in our controller here, we're accessing the query string and we're dereferencing it. It binds that as a JSON for us so we can dereference it as an object using the destructuring structure to get that start end. So I'm going to create a key that's start and then assign it a value of 0. And then I'm going to create a key that's end and start that at 1,000. And for each key value pair, I use an ampersand. So this is one way that I can send data to my backend. And this is a good way, since we're just building a backend service, to be able to explore how to do this without having to build some kind of mock dummy end either, or client side. So I'm going to hit enter on this and notice, oh, look at that. I got a success true and I got a game ID and it gave me the ID for that game to my client. And now if I look on my server, remember I had that console log for my create game. I have a key value pair. So notice this is actually returning the object, the dictionary of games, where the key is that key here, and the value is an object that has a collection of properties. Number is 947, the start is 0, the end is 100, and game over is false. And notice that start and end default as strings. So just keep that in mind when we go to do our game logic, that we'll have to parse those as integers. We'll have to go ahead and cast those into integers if we want to use arithmetic relations on those. Excellent. Let's move on to our next step, where we can actually go ahead and get a game back. So here we'll implement a REST endpoint where we can get data for a particular game instance. And in this iteration, we're going to implement using a URL parameter, right? Like, because if we want to get a particular instance of a game, we have to get it by its ID. So we're going to learn how to use, how to set up a route that could be anything. And then we'll, based off of what was given to us using server-side logic, decide what we give back. And so that's what's called a variable URL path, to be able to use parameters. Okay, perfect. So this will be a relatively short step as well. We only have 3 JavaScript steps, where we're going to add a getter method into our model. Then we'll add a getGame method into our controller. And then we'll add an endpoint that triggers our getGame callback function to change or do something with our model. Okay, so the first thing we need to do is we actually have to create that getter inside of our game server class. And then we'll take a look at what's happening. So, game model, yeah. So inside of our game model, we already have a game. So we're going to create a new instance method. And so here it's the role of this method is to get back an instance of game that's stored inside this games collection. We require an ID as a parameter. And the first thing we're going to check is if it's true that there is something at that ID. So keep in mind in JavaScript, and here I'll show you here. Let's go into developer tools. If I had a game object, right? Let's say that this is my games, right? Let's say that I have foo, and this is some value there. Okay, so if I go into games and if I type in foo, it returns something, and that something can count as a truthy value, right? Now, if I put in something that doesn't exist, let's say spam, that's undefined. Undefined counts as a falsy value. So just by trying to index with a key, if that key if it's not used for anything, then it won't trigger this if statement. So this will trigger the else. So if that key exists inside of the games, then I will access the game instance from that key. But look at what I'm going to do. I'm going to destructure it so that I take the passcode, the random number, out of it, because I want that to be private. I don't want to deliver that to the clients, right? That should be something that's always on the server side. So I'm going to extract that, and then I'm going to do that spread operator, the ... data, which is going to have all the properties of the game object except for the number. And then I'm going to return that data. So that'll have the min, it'll have the start value, it'll have the end value, it'll have the game over, but we're not going to deliver the random number to the client so that no one can cheat. Now, if this returns back undefined, then that means that that was an incorrect game ID. So then we'll return back to whatever invoked this get method, a null, to say there's nothing there. So, but we make sure that we return something, either a null reference or the game data that we want to be public. Okay, so after we do that, we have to go into our controllers class and actually create a callback function that will tell our model to try to get the game from our model. So let's go into our controller here. And so since this is a class, I can just create a new method. So I'm going to call this get game. It's going to take in a request and response, just like all of the callback functions that are attached to endpoints. Here, I'm going to do something slightly different. I'm going to access. I could have done this. So I could have done this. I could have done the destructuring and destructure the property, right? But just to highlight that we could do this in different ways, I'm going to instead use the dot operator to access the property ID from the parameters, from the request for parameters, and store that as a variable. And then from my game model that I imported up here, I'm going to invoke that get method we just created, and I'm going to send it that ID that came in from the request from the client, and that's going to return back data. Now, data can be one of two things from model, right? It can either be the data of the game or it can be null. So if data exists, now remember, null is a falsy value, an actual reference of an object is a truthy value. So if there is data that got returned back, if it's not null, then we're also going to add to that data a success key and tell it that was true. So the idea of telling the client whether the response was successful or not isn't part of the model's responsibilities, it's part of our controllers. Because so the controller's kind of observing for us, did the model change state the way that the client wants? And then it'll always let the client know, yeah, what your request was successful. And it's good to give that information so that you can have logic on the client side, be able to decide what to do in response to either a success or a failure. And then once we do that, then we're going to go ahead and respond back with that JSON, with that data, with that JSON that we send back. And if it's a null value, then there's no JSON yet. There's no object to go ahead and set properties into. So we're going to create a new anonymous object, right, with the key success. And this would be false, right? Because we weren't able to get the game. So we'll just say, oh, no, there wasn't an ID there effectively. Okay, so now that we have the callback function, we have to set up a route. So in order to set up the route, I have to go into my routes. And the first thing I'm going to do here is, what was that method called? Get game. So I'm going to go ahead and destructure that from the import, the object that I'm doing. And then I'm going to set up a route where the route is going to be, and again, all of my routes for this REST API is going to be get. So another get, and this is going to do /:ID. So :ID allows me, and so ID could have been anything, right? So the colon just allows me to define some random thing, some random property. And then I will invoke get game on that random or that variable URL. So one important thing that you should know about these variable routes is they should always go after your well-defined routes. Since they're not well-defined, it could obfuscate a route that is critical. So make sure that these go towards the end, just like variable length arguments inside of a parameter list. Okay. And that's it. We should be able to do npm start, launch our application, and test it out. So let's do this. We're going to test this in one of two ways. We're going to test to see if we can't get back. First, create a game. We already created a game, but I need to relaunch the server so it actually has all this logic. So let's kill this. Let's clear this. Let's relaunch our server. Okay, so our server is now launched. Let me refresh this. It's going to create a new game with a new ID. So notice I now have a new game with a new number, a start and end. Game over is false. Perfect. And this is on the server. So let's see if we can't then, now that we have that, let's see if we can't call this. Now we can't call it with this. We need to use the ID that our server has given to us. So here I'll go and we'll do localhost 3000/API/game. And then look at this. We're going to use not that one, this one. We'll just use the ID, the variable parameter here, right? That returned, and Express has a route for that. And it actually returns to me that game instance. And notice it's everything except for the passcode, right? So it lets me know what the minimal number is. It lets me know what the maximal number is. It lets me know whether the game is over or not. And it lets me know that that request to get the game was true. So that came from the controller. The rest of this came from the model. And again, the reason why we might need to know the start and the end would be because if we weren't the ones who created the game. Let's try that same thing, though. Let's try with this ID here that was given to us, or let's do not valid ID so we can see. And so here we're going to try the fail condition, just like we tried the success condition, not valid ID. We still get a response, right, which is good. And so now we know that our request failed on the server side because we gave the wrong ID. So if I were building a client, I would probably say, oh, there's no ID. There's no game ID for that, right? So I would know how to respond given this information from the server. Okay, the next iteration we want to do is we want to be able to actually implement where we can make a guess towards our HiLo game instance. So in this iteration, we'll use the route parameters again, but we'll create like a sub path into that endpoint so that we can issue a command to that game instance. So again, the route will use the parameter to allow a variable URL based off of the unique game ID, but then we'll do / and then like guess, so we can do something in response. Again, this will just be a 3-step process each time we go and do that. Usually what the steps are is we add some behavior into our model, and then we create some callback function that invokes our model to do that behavior. And then we create some endpoint that the client can invoke that'll cause that callback function to trigger. So notice we keep doing the 3 similar things again and again and again. So the first thing is, why don't we create the logic that allows us to do a guess inside of our game model? And remember, there's 5 different states we're going to do, and we're going to step through this really quick. So again, since our game server here is, okay, there we go. Since our game server is just a class, we can just keep making new instance methods. So we're going to create what looks like a big method, but it's relatively simple. It's going to be guess, and it's going to require 2 parameters, the ID for the game we're trying to access and the number we want to try to guess. So there's a couple of ways we can return. So one is if the ID is wrong, then we're just going to return null, right? Like there's nothing there to apply a guess to. So we're going to check the inverse. So if it's false that the game ID is there, then we return null. Then if it is there, we'll continue. We'll access that ID and grab the game object, the game instance there. Then we'll check, is game over already true? And if it is, then we're going to return this anonymous object, this key value pair, where guess is game over. Now, if the game isn't already over, then we're going to see if the number inside of our game is equal to the guess value. And if it is, then we're going to set game over equal to true. And then we're going to return to that user, you got it correct. Your guess was correct. Now, if the guess number is, if the passcode is higher than the guess, then we're going to return that guess, the key guess is too low. And notice I'm casting here, right? The plus sign allows me to cast a string into an integer, into a number. And then I'm going to check if the passcode is lower than the guess, then I'm going to say, oh, it was too high. I'm going to return too high. And if it's none of these things, then I'm like, some kind of error occurred. Some kind of error that maybe it wasn't a number that got sent, for instance. Maybe it was a letter or some reason that caused all these other instances to fail. And this way, we just alert the client to know, to try to resolve any possible outcome inside of our game model based off of these parameters. Okay, so now that we have that method made, let's go ahead and define our controller that will invoke that method from our server application, from our server logic. So let's go into controllers. And again, since controllers is a class, we just have to create a new instance method. And so here, the instance method we're going to create is going to be called gas. And again, just like all the other callback functions that tether to endpoints, it has to take in a request and a response. And in this instance, I do it in both ways, just to show you that I play no favorites. From the request, I'm going to access the parameters object, which has an ID property, and then I just save that. So that's one way I can reference a property of an object. Another way is I can just access the object and do a destructuring call on it and just access the property of guess that way, which would be some numerical value. Anyway, I'm going to get from between the parameters. So the parameter is the URL parameters, right? That's .id is defined. Let me show you. That's where ID is coming from. Line 7 from when I set up my router. So when I say parameters.id, it's going to give me that passcode that's part of the URL string. And then since we're using query strings to pass our data, we can also access data from our callback functions that way. So two different ways to access our callback functions. Excellent. Anyway, then from our game model, I'm going to invoke that method we just created, gas, and I'm going to pass it the ID that I got from the parameters, and I'm going to go ahead and pass in guess that I got from the query string, and that should give me back a result, one of a number of different results. If the result is something that exists, so the only time it doesn't exist, let's look back, is if the ID didn't exist, right? Any other time, it's going to either be guess game over, guess correct, guess too low, guess too high, or guess error. So if it's any one of those, then I'm also going to take that result and I'm going to create a new key success and put that it was true, and then send that back as a response as a JSON object. Now, if it was false, then I'm going to put that success was false. If I didn't get back an object from my game model, then clearly the guess didn't work. So I'm going to let the client know that their request didn't work. It was false. Excellent. And now the next thing I need to do is I got to set up an endpoint, right? I'll just grab this one. And so here, this was called gas. So when I go into my routes here, I'm going to dereference gas. And then I'm going to, on my express router, oh, not there. Actually, put it. Keep those comments there, but keep this together. Okay, on my express router, I'm going to create for a variable length of ID / gas. So if it was localhost :3000 / API / game / some ID / gas, I will call the gas callback function. Okay, let's actually test that out. Let's kill this. Let me clear my console. Let me do npm start. Let me refresh. Oh, that's not an ID anyway. So the first thing I need to do is I got to create a new game because I just relaunched my server. So now that's going to give me an ID. So let me use that ID, and I'm going to send that. So, okay, that's cool. So I got my game instance. So now and so if you recall, what I need to do here is I'm going to have to send a parameter of gas. And let's test a couple of different things here. So let's try on our gas, we're going to do a search parameter. So this is the endpoint. But since our data requires search parameters embedded into the string, I'm going to do the question mark, and the key is going to be gas. Because if you remember my code from here, right, we're looking to get a key of gas. And let's say we do nan here. Let's see, that's going to be a success was true to actually access, but I got an error response because I tried to guess not a number, right? So that's what allows me to get the final else in the if else chain there. Here, why don't we try a guess of 0? And so that allowed me to go through, but it was too low, right? Let me try 999. Okay, that was too high. Guess too high. All these are success true. Okay, let's see here. Yep. And wow, look at all these different ways I can test. Let me try to get it correct. I can try the correctness because I'm actually getting the results here. So 914. Oh no. So let me put 914 on the server. I got it correct. So now let me try it again. But now it's game over because the game state is false, right? The game over is now it's now no longer open for more guessing because someone already got it. And so those are all the different returns of the state that our game can be. Oh, and the last one would be but on not a valid ID. So let's try that. So let's just put let's change one of these letters or put another letter there. And yeah, success false. Excellent. Okay. The next thing we need to do here is the very last portion of our APIs, right? When we looked at our APIs originally, we said we needed to, we needed to be able to make a new game. We need to be able to get a game with a certain ID. We need to be able to get make a guess at a game at a certain ID. Now we just want to be able to reset a game at a certain ID if the game is over. And then we're effectively done with our REST API. There's just one small change we're going to do after this one. So here, we just need to implement a REST API to reset the game after it's over. And so in this iteration, we'll implement an endpoint that resets our game. And so the routes will use the parameters to allow the variable URL path, just like the last 2 times, so that we can access an actual game instance using the unique game ID. And the game must be over to reset it. And so resetting a game just toggles the game over from false and then also randomizes a new number. And so just like all the other times, it's just a 3-step process. We're going to define a reset method inside of our model. And then we're going to add a reset game callback function in our controller that tells our model to do something and gets information from an endpoint. And then we're going to create an endpoint on how that callback function gets triggered. So let's go in and actually just create our reset method inside of our game model. Change this to game server. Hope that didn't change all my formatting. Okay, let's kill this server for now. And then let's go into our game model here. And I'm going to create a reset method inside the class that's going to take in an ID. It's going to check to see if the ID exists, and if it exists, if game over is true or false. So if it's true that that game ID exists and it's true that the game is over, then I'm going to get that game instance. I'm going to generate a new random number for number inside the game. I'm going to set game over back to false. Then I'm going to get that new game instance. I'm going to destructure the passcode out of it because I'm going to send this new game instance as a reference to the client. And that's private data I don't want the client to have. And then I'm going to return data. And again, if it's either false, that is a good ID, or that the game over is not the game is over. So to avoid people from resetting an active game, we're just going to return a null. Excellent. So now let's go into our game controllers and actually create a callback function that can invoke that reset inside of our model. So I'm going to go into my controllers here. And since this is a class, I'll just add a new instance method, reset game. Just like all the others, it requires a request response objects passed into it. I'm going to get the ID from the parameters from the request. And then I'm going to, on the game model, invoke the reset method on that ID. And I'm going to get some result back. If the result is a true the response, right? If it's a game instance, then I'm going to add a key of success and then a value of true, and then return that back as a response as a JSON data to the client. And if it returned back null because the ID was not inside of the game's dictionary, or because the game isn't over, then I'm going to return success false. And then the last thing I need to do here is just go ahead and set that route to this callback function. So first of all, let me go ahead and I called it reset, I believe. Let me go back to controllers, reset game. So let me dereference reset game. And then on the express router, I'm going to set up a get for a get method on this route, variable ID / reset. We will invoke the reset game method. And that's it. We should be able to test this. So let's launch our app. Clear, let's launch our app. Let's go over here. Let's create a game. Okay, perfect. So we created a game. Oh, look, and you see, as I keep doing that, I think this is the first time I'm showing you, it's actually showing all the games that it's console logging out. So I have all these games that I can potentially utilize. And then let's go ahead and guess it so it's correct. So let's grab one of these games. I'll just grab this one here. No. And then we want to go to guess, and then guess is equal to, and let's see, that's the last one here. That's that's 644. So let's do 644. So I got it correct. So now let's call reset on that, and it should go ahead and reset it. So here, instead of that, let's reset. Yep, and notice now it gives me start and game over is false. Let me call reset again when the game over is false, and now that's a false. Perfect. And then also let me do a different ID, invalid ID. Invalid ID, right? And that's also a false. So just making sure that all the ways that my client can touch that endpoint, I get some back response. My client knows how to handle that. So yeah, I was able to go ahead and successfully reset the game. I tested that. I was able to successfully try to reset the game, but failed because it was in a not game over state. And then I used the wrong ID, and I also got a success false on that. And so the very last step we have isn't going to affect our implementation here. Like our implementation of our server is pretty much done. But in order for us, Next Lab, to build a client that'll actually use this API, that actually builds a client application side. And since we want to run both the client and the server on two different locations, we're going to have to allow our server to violate or ignore what's called CORS, cross-origin restrictions on our local host so that we can test this. So if we don't do this, then our client won't work. So keep that in mind when you're implementing this. And if you implement the next lab, if you skip iteration 8, your client's not going to work. So we need to use, we need in the request, we need to, or I'm sorry, in the response, we have to be able to allow this header in the access control allow origin. And so for the next lab, that'll allow us to build a front end that uses the REST API to implement our multiplayer number guessing game. And so we want to bypass these CORS restrictions on localhost. So to do this, we're just going to create actually our own middleware function. Probably the first time we've seen how to create our own middleware function. So here, what we'll do is we're going to go ahead and create our own function inside. Nope, that's Python code. Here we go. We're going to go inside of our app.js. We'll just create a function, right? It'll get hoisted. So this will be my own middleware module. So a middleware module, when you define it yourself, has 3 parameters, unlike the callback functions. The callback functions are the last thing that things usually occur on. So they get just the request response, but middleware gets request response and then a next parameter. The next parameter is fed to this function by Express itself based off of the ordering of the middleware modules that are placed. And a function, essentially it's just a function object. And it's the next function object in line that gets called until you get to the callback function. So it's possible that the next will be the callback function if there's no other middleware modules that are between when the request first comes in and where the callback function that's tethered to that endpoint finally gets invoked. So here we're going to embed into the responses header that we want to access control allow origin, and then we're going to invoke whatever next is, and that's defined by the Express app by passing it in as a parameter. So it's probably going to be the callback function of that endpoint and all endpoints. And then we actually have to go ahead and tell the app to use this middleware, which is, it's just a function, right? So notice when we go in here, before I get to the routes that I set up, so I put all my middleware before my routes. And so here I'm just going to pass it a reference to that function so it knows to go to use it. And that'll allow us to be able to use this code for next class. Excellent. And just to make sure this works, you know, you can just go ahead and kill and hit npm start. And if it launches, then we're good. Yeah. So that's today's lab. We, in one lab, learned how to implement a backend REST API for a multiplayer number guessing game. It covered route parameters, query strings, unique IDs, REST API designing and developing with REST APIs. And we learned how to export JavaScript modules and create endpoints. So ways you might want to improve this app: design a front end, because all we have is a back end set of calls, and that's what we'll be doing next lab. But other things you might want to consider doing if it were better would be like add usernames for a game and show the name and win record as a scoreboard, or synchronize users together and display who's playing. Maybe instead of using HTTP, you could do this with WebSockets. You might want to store the games in a database as opposed to just on the server, because if the server ever crashes, you lose all the active games, or if the server even goes to sleep. And maybe even deploy this into production on Heroku, so you can actually play it with multiple people instead of just on localhost. Maybe you can make a more fun theme on it, where the idea is that you have multiple people trying to hack into a system, and the first one who hacks it wins and everyone else loses. So you can kind of make like a cyber theme concept on the HiLo game to make it a little bit more interesting. Excellent. Well, is there any questions about this lab? If not, I will go ahead and end this video here, and I'll post it for all of those who were not able to stay for the entire time to view it later tonight.
Thank you, Professor.
Excellent.
See you soon.
Have a great one, everyone. I'll see you all on Thursday, where we'll build the client side of this app.